What's up everyone, welcome to Stockton. It's a pleasure to meet all of you. On this channel, we talk about stocks before they start blowing up, say goodbye to chasing stocks at all-time highs, and say hello to making some money. So if this sounds like something you want to take advantage of, then hit that beautiful subscribe button and like the video. Now let's get to it. Before we get into the video, I have to say that I'm not a financial advisor. Anything I say is just my opinion and is for entertainment purposes only. Having said that, if I'm talking about a company, I'll let you know whether I'm personally going to invest in it or not towards the end of the video. But you should always do your own due diligence, so with that out of the way, let's get started.
In order to answer the question of whether Bionano is better than Pacific Biosciences or Illumina in terms of their technology, we have to take a step back and understand a few basic things. In addition to not being a financial advisor, unfortunately I'm also not a scientist. But here's what I've learned so far. Currently, there are three main players in the gene sequencing space: Illumina, Pacific Biosciences, and Oxford Nanopore Technologies. Out of these three, only two are publicly traded companies, that is Illumina and Pacific Biosciences. And now we have Bionano, which isn't as big as the other two companies, but the technology seems to be really good. But in order to see what the future holds, we have to step back and learn from the past. So let's go back and see how Illumina changed the game with their next generation sequencing when it first came out. To give you some context, the Human Genome Project took over 10 years and cost nearly $3 billion to complete. Next generation sequencing made large-scale whole genome sequencing accessible and practical for the average researcher. However, scientists soon found out that next generation sequencing has its limitations. Illumina uses short-read sequencing, which isn't suitable in all scenarios. And this is where Pacific Biosciences came into play. Pacific Biosciences came out with their long-read sequencing technology. Long-read sequencing can sequence parts of the genome that cannot easily be sequenced by short-read sequencing. I'm aware I've said the word sequencing like a billion times. But basically what this means is that when Pacific Biosciences came out with their technology, it helped address the issues that Illumina was facing with their next generation sequencing. However, then scientists found out that long-read sequencing has its issues as well when it comes to accuracy, and this is where Bionano comes in. I've found multiple research papers that state how using Bionano in conjunction with long-read sequencing technologies, such as that provided by Pacific Biosciences, greatly enhances the accuracy when it comes to the detection of structural variants. I'll just read a few sentences from a couple of research papers to give you an idea. So this one I actually found really interesting because this is from a case study done by Pacific Biosciences themselves in 2015. So this would be before Bionano launched their Sapphire model. NGM from Bionano Genomics produces an accurate representation of very long single molecules ranging in length from 150,000 base pairs to more than 1 million base pairs. Treated with nicking enzymes and digitized as they flow through the iris chip, these individual molecules yield unadulterated long-range information without PCR bias, allowing users to generate comprehensive and accurate de novo assemblies. The pairing of these orthogonal technologies produces a more complete and higher quality genome assembly than either solution offers on its own. Scientists report that PACBIO data provides the most contiguous assembly for use with the Bionano map, while Bionano maps enhance the long-range scaffolding and accuracy of Pacific Biosciences assemblies. So Pacific Biosciences themselves are saying this, that when you pair Pacific Biosciences technology with Bionano's technology, you get a higher quality genome assembly than either of the solution provides on its own. Now this is from another research paper, and it sounds like this was the very first research that was done where they combined long-read sequencing with Bionano's technology. So this is what they're saying. It also represents one of the very first genomes assembled by combining smart long-read sequencing with the new Bionano DLS technology for scaffolding. The quality of this assembly demonstrates the potential of this methodology to substantially increase the contiguity of genome assemblies. So again, what they're saying is that when you combine these two together, you get a higher quality genome assembly. So it seems like Bionano could become an integral part of long-read sequencing tech in the years to come. But according to Bionano, their tech can also be used just as a standalone solution to detecting structural variants, so you don't actually have to pair it with other technologies. They also claim that they can read more base pairs than an average long-read sequencing technology does. Have a look at this video by Joe Butler, who apparently works at Bionano.
Is what's the average size molecule of DNA that you image? If this bead is 500 base pairs, it represents a good size for short-range sequencing. 20 beads would make up a 10 kb fragment, typical for long-range sequencing. Bionano, on the other hand, when we add the labels, gives you a good perspective of just how long those molecules are. The average length of molecule that we image is 250 kb. Just to put it in perspective, you can also see what a good job I did at cleaning the table.
Of the trillions of cells that compose our body, from neurons that relay signals throughout the brain to immune cells that help defend our bodies from constant external assault, almost every one contains the same 3 billion DNA base pairs. 3 billion! That's a lot of base pairs that you need to read or sequence. So the greater the number of base pairs you can read or sequence, the better it is. And in this case, they're claiming that they can read the most number of base pairs. In contrast to Bionano, long-read sequencing technologies generally read lengths of about 10,000 to 100,000 base pairs on average, whereas Bionano can read up to 250,000 base pairs. So it sounds like Bionano is the leader in this department. So with Bionano being more cost-effective and being able to read more base pairs than the average long-read sequencing technology, it does have quite a few things going for it. So is Bionano better than Pacific Biosciences? I'm afraid that the answer to that question isn't that straightforward. It all depends on what the scientist actually wants to achieve and what the situation is. In some cases, short-read sequencing is the preferred choice. In others, long-read sequencing or optical mapping might be a better choice. The fact is that the pie is large enough for all three techniques and companies to flourish in the years ahead. With Bionano, obviously they need to still execute on the business plan because they're a very small company and there's a lot of risk still involved, but the potential for this company is huge. So that's it for today, guys. If you liked the video, give it a thumbs up and subscribe to the channel. It really helps with the YouTube algorithm. Have an amazing day and I'll see you in the next one.